Hello, my name is Emmanuel Mathot from TerraDoué. So I'm going to present you today how we used OpenNebula in our business to actually make an enabled product that actually for business. I will try to make a presentation which presents what we do, but also going into technical features. So there will be for every tenant. So if you have questions about technical stuff, please ask at the end. We will go through, let's say, our world. I don't know why it's flashy like this. From the development area to our operational and operational products. So first of all, just for background, we are a company which works on exploit and strengthen the best practices on distributed computing. Our first base is grid computing with a platform called GPod at ESA. We had an initial middleware cloud experience in 2006 with a Gridway, which is, I think, an ancestry of OpenNebula adaptation for the cloud. We also had other experience using Amazon. But the first integrated solution with OpenNebula was, again, at ESA with a project spelled CIOP, you pronounce CHOP, which had aimed at having what we call today the developer cloud sandbox, which is a virtual machine ready for earth science users to integrate their workflow processor, their algorithm. Because our core business, or let's say our core expertise, is earth science. And to take a phrase from Dr. Tim from this morning, it's science is increasingly turning to complex multi-phase workflow, and it is true. This is what we try to do with our solutions, to provide the platform as a service for those users to exploit their algorithm on a cloud paradigm. We have many projects with like an e-collaboration platform where users challenge each other on their workflows, science workflows. We also developed the next generation of data dissemination for ESA, European Commission Sentinel Synergy Framework, or ECCP platform. Those projects will be explained better. Some of those projects will be explained better by Jordi Fares tomorrow morning. So to come back to our system, let's start with the development platform, development environment, where we mainly develop extensions around OpenNebula. So first of all, and this is going to be technical in those slides, we worked on the hooks. In the first version of OpenNebula 3, the early 3 releases, we started with the hooks. The first hook that were enabled into OpenNebula was the hook over a virtual machine, allowing to cover failure of the virtual machine, restarting it, etc. But as I said, we provide the platform as a service for specific user with specific tools in it. So we needed some things to challenge also user issues, network, and security. That's why we developed around that certification process for the user, which is a grid legacy. All our system is secured with using user certificates. We needed also a strength contextualization profile per user, because as I said, we need those user information to build the best virtual machine, the most adapted, customized virtual machine for the user, and to enable it for him to integrate, because this user is not aware of the cloud paradigm. He just wants something ready to run, ready to work with on his machine. And of course, two more important aspects, which are the network and the security. We needed to have those machines accessible easily, quickly, in an efficient way, but also secured. We integrated it with the system like DHCP, DNS, but also isolated the user through VLAN, and of course routing firewalls, and so on, to be sure. So we accompany this with first hook we developed by ourselves, but then contributing on the ecosystem of OpenNebula, new hooks came over to handle also user, to handle also the network. Then we worked also on the driver part of OpenNebula. We contributed to the VMware driver for the storage, because in our first project shop, we needed to exploit VMware infrastructure. So we needed, let's say the first driver were not so efficient for us. It didn't satisfy us completely, so we had to use the command line tool of VMware to transfer the images, for example, from the storage to the hypervisor. Also some dedicated execution driver. Since then, the VMware driver has evolved into OpenNebula and gives even a more better performance. We developed another driver, which is an hybrid driver, this one, DSI41, which is available on GitHub, which is more a driver to provision a virtual machine on T-System business-to-business private cloud. This is not a general user driver to be used, because you need an agreement with this company to open. But this was, let's say, the first driver hybrid we developed inside OpenNebula to exploit multi-cloud bursting. And then the last we developed, and we will push online soon, which is the gclouds for one. This one, it's more ambitious because it's powered by gcloud slab command line interface. So in principle, it's able to provision virtual resources on any gcloud cloud provider gclouds enabled interface. Our first test, and the tests we have done so far, are done with the Abiquo API, which is part of the gcloud, tested on Interroot. The first, I will show you some screenshot. The tests are very successful, and we would like to extend this gclouds for one, because I think it's very powerful to go to other cloud providers. And then, to mention it as well, even if we didn't work so much on it, but more used it, is OCCI, especially for our third-party system, web portals to communicate with OpenNebula. We did the choice of using OCCI, and since then, we are following OCCI evolution. So, okay, this is to show you the late test we did with OpenNebula 4.2. You see that we started a VPN gateway on Interroot using the gcloud driver. So basically what we do is we start first a machine, which is a VPN gateway at the cloud providers, and then we start our other machines, the virtual machines, and they are available because on the contrary of Amazon, you don't have always an IP, a free IP available. So you create virtual networks on the cloud provider, then you deploy a gateway. This for us is very important because, again, we have non-computer scientist user. They need to connect to our web portal, and they need to have access to their machine transparently. Either the machine is on a private cloud, on a private infrastructure, or on a scalable cloud provider. Then another important work we do in development is the virtual machine contextualization, because again, it's very important that the machine is prepared and has the context the user wants to work on it. So we first of all have complex user profile. When I say complex, it's not only username and public SSH key. We need also to push the certificates, the ID of the user inside our infrastructure, the online support key, those kind of information that makes the user aware of the tools he uses, etc. We have also another layer into the virtual machine, which brings really the platform as a service, which is the application layer. In this application layer, the user transform its algorithm into an application, and we have an application disk, so which is separate from the OS, where the user has at the end his application ready as an external disk. You would see in a bare metal machine, it would be a USB disk that you plug into your machine. It can save it, put it on the shelf, and then take it again for starting another VM. This application disk is powered by a processing framework which is wrapped up around Hadoop and UZI. Hadoop for the parallelism and the parallelism and the splitting of the task around a cluster, and UZI to manage the workflows. So as I say, we really provide a platform as a service, and that's why we work a lot on the contextualization of the virtual machine. Finally, the last layer on which we work, and lately, is the visualization layer. Thanks to the last release of OpenNebula, there is a new Sunstone, really easy to play with. The concept of view is really nice, so that we can create view for user. For example, we create a sandbox view. We can also modify the tabs in such a way that a user has only the information he needs, not many information that he doesn't care about. He has control over minimum stuff, starting, stopping, saving a disk. He doesn't need to reboot hard. He just have the control he needs. And a small link to his dashboard that I will show you in the next screen. We also worked on the wizard to create a machine. So before you had, of course, a template, an OS, and let's start the machine here. We are still working on it, the application layer where the user can take his off-the-shelf extra drive with his application to put in on it. But also, we hope in the future having some kind of even evolved wizard where the user really selects the package he wants on his virtual machine. This is the dashboard we bring to the user to connect to this to his machine. It's using OCCI to connect to and to know, for example, the network information. When he is connected to our VPN, he directly has the host name to connect to. He can bring his private key, because this is also something sometimes not easy to understand, how to transform an SSH, a PEM key into SSH, etc. Everything is done from this mini portal. It also has some interface to play and to debug its own workflow. We are really at the application level here, and the user can debug, try, test, and use the UZI and the Hadoop interface to watch his log, etc. He also has an interface to test his application over WPS, so the web processing service. So his application has, the sandbox has a built-in WPS server on which the user has his application ready to start. So when this application is finished, he can plug it to another machine. It's still enabled on WPS. And some health tabs to see how and to manage more control on it, on the service. This slide just to show you, as we said before, we don't have a big infrastructure. We are an SME, and we don't have petabytes of disk, etc. We have even recycled a grid cluster to make our lab of development. We are working today on development on OpenNebula 4.2.0, and in operations we are still at 3.8. We plan an update to 4.2 in late October. We are still testing new information, and we would like to bring to the user the novelty in the development quite soon. All of that is part of a continuous integration process, powered also by OpenNebula over virtual machines. So all the developments are put into this continuous integration process to make packages that will enable our solution over OpenNebula. So here, in this case, we have a complete process of testing, packaging, release, etc. that brings our system into operations. In operations, we have a more structured environment, of course. This structured environment is powered by our core product, which is the Cloud Controller Box. The Cloud Controller Box is, of course, an OpenNebula instance, on which on the top you have all the features I have presented before as a package from TerraDue, and that are built on the top of OpenNebula. So you can find what I explained about the hooks, the contextualization for Hadoop, for the sandbox, the virtualization with our custom VMware driver, the hybrid for scalability to G-Clouds or DSI, but also the integration with our network infrastructure and some specific storage driver. So this is the technical sheet of our typical product we work with OpenNebula in operation. What does it bring to? It brings then network insecurity. When you start a machine, it injects automatically in the DHCP the configuration of the future virtual machine that will be booted with the DNS dynamic updates. The VM is placed into a VLAN, isolated from other group of users. We adapt, of course, the firewall, the routing. So it's a lot of scripts that are handled by the hooks, and also the VPN dynamic rules to give the user access to his machine once it's booted, etc., etc. User management, of course. The certificate of the user is injected into OpenNebula, into our instance. So when a user starts, he has his certificate, public key, of course, in the machine. He is also into a decentralized directory where he will have access to his online support using his password or, again, his certificate. OpenNebula then enables the developer cloud sandboxes, which, as I already said, is the environment for the users, the scientists, to integrate their application. It's completed by a Earth Science toolbox, so that are tools to access data in different data, virtual archives, etc. It also enables a complete Hadoop MapReduce processing framework. This Hadoop processing framework is wrapped up with command line tools, more, let's say, easy to assimilate for a non-aware paradigm user. And of course, Uzi provides the powerful scheme for the complex workflow. Then I will show it later in another later slide, but the idea is when the application is ready, is of course to bring it to a more powerful cluster for very large processing, because we are speaking about Earth science, we are speaking about Earth observation data. It's petabytes of data to process that are stored in a virtual archive. So we need to, when the application is ready, to bring it and to scale up into a more powerful cluster and to provide the processing. So again, we are using AppFlow to deploy Hadoop cluster service with a large dataset processing campaign, and then also retrieval of the results, of course, which is the objective of the user. And the last product, let's say, we have enabled, and we're still working on it and trying to bring into surface, let's say, is the appliance pay-as-you-go. Let's say it's when the user considers his application ready, he wants to share it with the community. He puts it in the digital marketplace as a virtual appliance. The user, that other user of the community can bring up, start a custom processing, stop it, and you can subscribe to some appliances. This is a model we are trying to develop and to push in the system. I will now go into what we call the business scenario. It can seem a bit complex like this, but it's just to show you how we interact with OpenNebula and what we do. So at the first, a user comes into our system, and he registers simply on our web portal. This registration here brings the generation of the user inside our centralized repository, generate the certificates. These certificates, public key and user information. Let's go into an OpenNebula user account. The user, of course, retrieves its own certificates, its own private key, and also all this information are also put into our VPN gateway, which will be the main access point for the user to his cloud infrastructure. So once he has his own account, he is directed to the dashboard. Let's say for the moment we have a dedicated dashboard, dedicated web portal, but in the future, as I showed you, we count of relying on the views of OpenNebula and the tabs, etc. And the user then starts its own machine. What is important is that everything is injected into the virtual machine. The virtual machine gets its IP from the DHCP server. It also brings all the routes, the firewall rules, etc. into the VPN gateway. And then the user starts working directly using its private key and the VPN gateway into his virtual machine. This can last for weeks, months. User can stop the machine. We have also control over the virtual appliances in which we can shut them down for maintenance. We have a complete control. If we realize that the machine is unused, we can inform the user, ask him to stop, etc. But the most important is that when he has finished, he saves his application as a disk. He packages it. In the future, we should have, and we will have more format of export of his application. But most important is that he's able then to start larger clusters with this application for larger processing campaign. And he also may publish its application as virtual appliances that other user can directly order, can directly ask for us to boot up, to make the process via the WPS, via another scheme, or using the marketplace. Other OpenNebula instance could also download and try by yourself on their own instance. This can be, of course, brought into the multi-cloud system. That's what the big arrow means. So what we hope is to be able to bring to provision, let's say, this scheme, those virtual machines, those sandbox, those clusters, Hadoop clusters, into other external cloud provider for scalability using the driver I presented you before, and to have at the end a complete chain, for the earth science that pass by deploying virtual archive that receive the data with long-term, short-term, but that has the data, users that develop their own application based on those data, and then that starts clusters to process, but also expose or distribute the virtual appliance, the application, their algorithm, using always OpenNebula and the different drivers to go to different cloud providers. So this is what we call curate and deliver scientific information from raw data to publication. So this is the main overview of our, let's say, ecosystem inside the company. This is my final slide. I want to thank, of course, all my developer team. You can have the contact here if you are more interested in the marketing or in the solution itself. We are proud to announce that last week we have signed an agreement with C12G as a channel partner, and we hope it will lead to more evolution and even better solutions. And that is for now. So if you have any question, please don't hesitate to ask.
About the VMware drivers, we were working on some drivers in the past, and we get a chance to try new ones. So are you happy with them?
So it's a question about the VMware driver on which we worked in the past, and now what are we doing with it? Actually, we have a driver that is has been proved and working with OpenNebula 3.8. To be honest, currently we didn't get into it again. We are tasked to test the new one of the remodeled one from 4, for OpenNebula 4. If it fits us our requisite, I think we will move it completely. But it's actually one of the blocking point of going to the 4.2 is because we are fixed with this driver we made by ourselves, and we have many projects that runs over VMware, and so we need also to go through that blocks. Yeah. Yes.
Why did you choose data instead of
it was just the objective of a project. At the requirements phase, we needed the interface that gather the most cloud providers, and we made just a table with all the interface, all the cloud providers, and JCloud was the one fitting the best. So now we know very well the arcane of the system, so bringing up a new driver is very easy for us. We just need a command line interface working well, and then we deliver it. JCloud's actually, we also chose to go to JCloud's Labs command line interface, because when you see the list of cloud providers available with them, it opens to a lot of cloud providers. So I hope this, when we will push it on GitHub, probably next week, when we will have a first release working and test it fully, we hope to have a contribution, we hope to have reviews, and that could lead to a driver that could be maintained by the community. Okay.